Welcome to the Deep Dive. We're here to cut through the noise and give you the essential insights you need. Today, we're tackling a topic that's, it's completely reshaping higher education, artificial intelligence. And look, we're not talking sci-fi futures here. This is about the AI working right now in your institution. Think about the predictive text on your phone, those course suggestions in Canvas, maybe even the chatbot that answers questions late at night. AI is already here. It's everywhere, often invisible.
It really is a kind of silent revolution happening under the surface. And because it's often hidden, people tend to rely on, myths or what they've seen in movies, which frankly leads to some significant challenges, especially around governance. So our mission today is pretty straightforward. Give you a solid, jargon-free foundation. We'll unpack what AI actually is, how systems like ChatGPT really learn, and get clear on the difference between real-world tools and those sci-fi ideas, all geared towards helping you understand its role in education. We're grounding this conversation in foundational research, but also very recent survey data, specifically looking at how AI is being used and developed right now in academic settings, stuff relevant to your daily work.
Okay, let's start at the very beginning, the absolute basics. When we say artificial intelligence, what are we actually talking about?
At its core, AI refers to computer systems built to do tasks that historically needed human intelligence. So things like recognizing patterns, making decisions based on data, understanding language or maybe classifying it is better, and solving certain kinds of problems.
Right. But when I hear that, my mind immediately goes to, HAL 9000 or something, a machine that thinks like a person. And that's the first big hurdle, isn't it? That common misconception.
Absolutely. That sci-fi image. That's the critical misunderstanding we need to clear up right away. The AI we use today, pretty much all of it, consists of highly specialized tools. They are not general-purpose thinking machines, not even close. In higher ed, the AI you encounter are systems designed for very specific things. Crunching huge amounts of text or data, spotting patterns in that data, making predictions, generating new content based on examples it's seen, or automating really routine tasks.
Okay, but practical example might help here. Like email spam filters. Everyone uses them, but nobody really thinks of them as AI.
Perfect example. That system learned from millions, maybe billions of emails. It figured out the statistical patterns, certain words, sender details, weird formatting that tend to mark an email as spam versus legitimate. It's good at classifying, making that decision, but it doesn't understand the email's content or why you might find a marketing email annoying. It just sees patterns. It's pattern matching.
Okay, that idea of specialization, of being a tool for one job, that leads us nicely into the main types of AI, right?
Mm-hmm.
We should probably start with narrow AI.
Yes, narrow AI, also called artificial narrow intelligence, or ANI. This is basically, it's all the AI currently in practical use. It's defined by its limits. It does one specific task or a closely related set of tasks really well. It's domain specific.
We bump into it all the time in academia, like Google Translate for checking a phrase, or the recommendation engine on the library site suggesting articles, or Turnitin checking for plagiarism.
Exactly. All narrow AI. And the key limitation, the thing to really grasp, is that these skills don't transfer. An AI brilliant at predicting student enrollment can't suddenly grade essays effectively. The underlying tech is completely different. It's built for one purpose.
And just to get it out of the way, artificial general intelligence, AGI, the thinking machine.
Still theoretical, purely science fiction at this point. It's got human-like cognitive abilities across many domains. Interesting concept, but not something we need to worry about for today's policy or teaching practices.
Got it. So AGI is off the table for now. But if narrow AI is everything, where does generative AI fit? Because that term has just exploded in the last couple of years.
Right. Generative AI is a really powerful and very visible subset of narrow AI. What makes it significant and why everyone's talking about it is its ability to create new content. Text, images, computer code, music. It's not just classifying or predicting, it's generating.
And this is the domain of the large language models, the LLMs, ChatGPT, Claude, Gemini, and others. And they've swept through universities because they can do things like, draft essays, help structure arguments, generate quiz questions, summarize really dense articles, even help students debug code. The accessibility is key.
And the adoption rates reflect that accessibility. Here's a number that really hammers it home. By late 2023, global student usage of generative AI tools hit somewhere between 86 and 92%.
Wow, 86 to 92%.
Yes, this isn't some future trend. This is right now. It's how a massive majority of students are engaging with information and, frankly, completing assignments.
Well, that changes everything, doesn't it? If you're teaching 100 students, you have to assume maybe 90 of them are using these tools in some capacity for your course. How you design assignments, how you assess learning, it all has to adapt.
It fundamentally shifts the ground rules. But to navigate this, to use these tools responsibly, or even just understand what students are doing, you need to know a bit about how they work. Which brings us to the engine room. Machine learning, or ML. How is this different from, say, traditional computer programming?
My understanding of traditional programming was always a human writes very specific step-by-step instructions, the rules, and the computer just follows them exactly.
That's spot on. You want software to calculate a final grade. You write the precise code telling it how to weight assignments, participation, exams, every single rule. Machine learning flips that completely. Instead of writing rules, you feed the system examples, huge amounts of data, and you essentially let the system figure out the patterns, the correlations, the distinguishing features for itself. So, going back to spam, instead of listing forbidden words, you show it millions of examples of spam and millions of examples of not spam, and the ML model builds its own internal, complex statistical definition of what spam looks like.
Okay, that distinction makes sense. Discovering patterns versus following explicit human rules. But that implies, well, everything depends on the examples you feed it, right? The training data, its quality, its representativeness. That must be crucial.
That is the absolute critical point, especially for education. The quality, diversity, and potential biases in that training data directly shape how the AI performs, and crucially, how fair it is. Think about an AI tool designed to give feedback on student writing. If it was mostly trained on essays from, say, native English speakers at elite universities, how well will it evaluate, or how fairly will it score writing from students with different linguistic backgrounds or different cultural styles? It might struggle, or worse, penalize them unfairly.
Which leads us directly to the LLMs, the large language models. They're trained on just unimaginable amounts of text, the internet, books, articles. So when you ask ChatGPT about, I don't know, the causes of the French Revolution, and it spits out a coherent, seemingly knowledgeable paragraph. It's what's happening. Is it thinking? Is it remembering facts?
It's doing something fascinating, but it's not thinking or understanding like a human. It's learned the statistical relationships between words and phrases and concepts. It's built this incredibly complex map of language, how words tend to follow other words, how sentences are structured, what topics relate to each other based on the massive data set it ingested.
But hold on. If the output is so good, it can sometimes fool experienced educators. Doesn't that function as understanding in a practical sense? How do we explain that gap to someone using it?
That's the tricky part. We explain it by going back to the mechanics. These are extremely sophisticated pattern matching systems. They are predicting the most statistically probable next word or sentence based on the prompt and the patterns learned during training. They are amazing at summarizing, rephrasing, and structuring information that already exists in their training data. But they don't have personal experiences, genuine comprehension, beliefs, or the ability to truly reason or create genuinely novel ideas.
And this lack of real understanding, this reliance on statistical probability, that's why they sometimes just make things up, right? The hallucination problem.
Precisely. Hallucinations happen when the statistically most likely sequence of words forms a statement that is factually wrong, nonsensical, or completely fabricated. The model prioritizes linguistic coherence, making plausible-sounding text over factual accuracy because its core function is language prediction, not truth verification. They're assistants, summarizers. They absolutely cannot replace deep human expertise or critical judgment.
Okay, so knowing these limitations that are specialized, data-dependent pattern predictors, not thinkers, helps debunk some common myths. Let's tackle a few we hear all the time in higher ed. Myth number 1, AI is going to take everyone's jobs.
Yeah.
Faculty, staff, we're all doomed.
Highly unlikely. It's much more probable that AI will change jobs rather than eliminate them wholesale. It's an augmentation tool. Faculty will still be crucial for designing curricula, mentoring students, handling complex ethical issues in grading, conducting original research. AI might help with automating first-pass grading on multiple choice quizzes or generating initial drafts of announcements, the routine stuff.
Okay, myth number 2, and this ties right back to the data issue. AI systems are objective and neutral.
Definitely false. As we discussed, AI models inherit and can even amplify biases present in their training data. And biases can creep in during the design and goal setting phases too. This is why human oversight is absolutely non-negotiable, especially in high-stakes areas like admissions or assessment. An AI tool might systematically disadvantage a certain group of students without anyone noticing unless a human is actively monitoring and evaluating its outputs for fairness.
Right. Myth 3. Newer, more complex AI is always better.
Not necessarily. We often fall into the trap of thinking more sophisticated means more useful. Sometimes, a simpler, more focused AI tool is far better for a specific task. Think about student support. Maybe a basic automated reminder system for deadlines is actually more helpful and reliable for student retention than a super complex AI advisor that sometimes gives confusing or slightly off-base guidance. Complexity isn't always the answer.
And the last big one. AI can perfectly predict the future.
No, AI finds patterns in past data. It makes predictions assuming future trends will resemble past trends. It can account for black swan events, sudden major shifts in the economy or society, individual student crises, or innovative new teaching methods that aren't reflected in its historical data. Its crystal ball only looks backwards.
Okay, so with those myths cleared up, let's talk reality. If the tech is narrow, potentially biased, and based on past patterns, what does AI use actually look like in higher education today? We touched on that staggering student adoption rate.
It's becoming incredibly routine, almost mundane across the board. Recent surveys show something like 84% of higher education professionals are already using AI in some capacity. And even more tellingly, 93% expect their institution's use of AI to increase, likely significantly, in the next couple of years. The momentum is huge.
And for students, that 86 to 92% group, what are they using it for specifically?
All sorts of things. Adaptive learning platforms in their LMS that adjust difficulty, writing assistance tools for grammar, style, even idea generation, 247 virtual tutoring bots, accessibility tools like real-time transcription or translation. It's deeply integrated into their workflow.
But faculty adoption seems to lag behind student use quite a bit.
It does. The numbers there are more in the range of 22% to maybe 61%, depending on the specific tool and survey. Faculty are using it for things like automated grading tools, plagiarism detection, which has been around a while, looking at student engagement analytics dashboards, or generating first drafts of quizzes and other course content.
And then there's the institutional level, the operational side.
Right. It's really baked into the back office now. Enrollment management, trying to predict course demand, financial aid offices, optimizing awards, even managing campus facilities or enhancing cybersecurity. AI is running behind the scenes everywhere.
But here's the kicker, the statistic that really stands out.
The policy gap, yes. Despite this widespread, rapidly growing use by students, faculty, and the institution itself, only about 23% of institutions currently have clear... Good question. Principle 1 has to be, start with the problem, not the tool. Don't just jump on the AI bandwagon because it's new and shiny. Identify a specific, concrete challenge you're facing. Maybe it's improving feedback turnaround time, or providing better accessibility, or easing administrative load, and then see if AI is the right tool to help address that specific problem.
Makes sense. Don't let the tech drive the pedagogy. Principle 2.
Understand the limitations, critically. You need to know what the AI can't do. Where does it fail? What are its known weaknesses, like bias or hallucination? Recognizing those boundaries is absolutely essential for knowing when human judgment, human intervention, is not just helpful, but necessary.
Which leads directly to the next one I mentioned.
Well, exactly. Principle 3, maintain human oversight. Always, especially for anything high stakes. Given the potential for bias and error, AI functions best as a co-pilot, an assistant, something that augments human capabilities. Humans need to be in the loop to catch errors, ensure fairness, and make the final call. Don't automate critical judgment.
And the last one touches on something we mentioned earlier, the data.
Yes, Principle 4. Consider data and privacy. AI systems need data to function, often vast amounts of it. You have to ask, what data is this tool using? Is it sensitive student data, faculty data? Where is it stored? Who has access? How is it being protected? Understanding the data pipeline is crucial for responsible and ethical implementation. You need clear data governance.
Okay, let's try to synthesize this. We've covered a lot of ground. The AI we have now is narrow AI, specialized tools. Machine learning allows these tools to learn from patterns in data, not explicit rules. And generative AI, like LLMs, creates new content by predicting statistically likely sequences, but without real understanding. Is that a fair summary?
That captures the core technical concepts, yes. And if you bring it back to the day-to-day reality in higher education, using these tools effectively and ethically really boils down to two key things. First, constantly being aware of the potential for bias embedded in the training data and the algorithms themselves. And second, religiously prioritizing human oversight and judgment, especially when the stakes are high for students or the institution.
That brings us to our final thought for you, the listener, to mull over. We've established that student AI adoption is sky high, maybe 92%. Yet the vast majority of institutions, around 77%, lack formal AI policies to guide its use. So the provocative question is, what are the immediate practical challenges, pedagogical, ethical, operational, that this huge governance gap creates right now for faculty and staff trying to maintain academic integrity and ensure fair outcomes in their daily work? What tensions arise today from that gap? Something to think about.